Okay, we're looking at section 4.2, graphing linear equations. We're going to graph a linear equation using a table or list of values. We're going to look at horizontal and vertical lines. We've got a couple definitions first. First one is the solution of an equation. A solution of an equation in two variables x and y is an ordered pair xy that makes the equation true. So if it comes out to be true at the end, it's going to be a solution. If it doesn't, it won't be a solution. We actually talked about that before. We'll look at what it means when you're looking at equations and graphs of equations today. Definition of a graph an equation. It's in x and y, two variables with a set of all points x and y, where there's an infinite amount. Everything you plug in, some will be the numbers we like to use are the integers, the ones that come out to be whole numbers, not all of the fractions and partial numbers and stuff like that. But there's an infinite amount of all of those partial numbers that will fit on that line to make it true. That's what it means by the graph of it. First example is verifying the solutions. The first one, 3, -4. You have an x value and a y value. X is first, then y. You're just plugging those into the equation right here. 2x plus 3y equals -6. And you're seeing if it comes out to be true. Um, so we're plugging in x in place of 3 in place of x and -4 in place of y. 2 times 3 is 6, and 3 times -4 is -12. So it gives you 6 minus 12, which leaves you with -6 equals -6. That is a true statement, so it is a solution. And when you go and you look back at that point, 3, -4, remember 3 tells you to go to the right 3 times. So from the origin, you're going once, two, 3 times, and down, since it says -4, down 1, 2, 3, 4. Notice that that point falls on that line, 3, -4. So that's how you can visually check it and algebraically check it. The second one was -4, +1. Again, where x is -4 and +1 is y. It's not a solution because when we plug them in, -4 in place of x and 1 in place of y, 2 times -4 is -8, and 3 times 1 is +3. So -8 plus 3 gives you -5 equals -6. That's not a true statement. -5, -6, so it's not a solution. Again, when you plug them in, though, -4 tells you to go to the left 4 times, +1 tells you to go up once. So -1, 2, 3, 4, and +1. Notice you're close to the line, but it doesn't pass through that point. That's why it's not a solution. As far as steps for graphing a linear equation, step one, you want to rewrite it in function form if necessary. Now, function form is y equals all by itself. That's what it means to be function form, y equals. We're going to take it one step further, and we're going to say write it in slope-intercept form. Y equals mx plus b, where you put in the variable term first. And that's going to make it a whole lot easier come next week when we introduce slope-intercept form. Step two is to choose a few values of x. Now notice it says choose. Don't choose numbers that are hard to deal with. As a rule of thumb, use easy numbers like -2, -1, 0, 1, and 2. Always use those unless they're going to give you a number that's not an integer, and we'll look at it in a second what that means. Because it's very easy for most of us to multiply by 2, to multiply by 1 and 0 and stuff like that. It's a whole lot easier. We can do those in our heads very quickly. To make a table of values and then plot. Once you get an x and you run through the equation and get your x and y values, go ahead and plot each of them using on it and create a graph. So for example number one, rewrite the equation in function form. X plus 4y equals 4. First step, you want to subtract 4 from both sides because you want this x to go over to the right side. It's positive, so you need to subtract x. Then you're left with 4y equals -x plus 4. That says 4 times y. So the second step, you want to divide by 4. But remember, you got to divide 4 by both terms, by the -1x and by the +4. And that's where you get the equation y equals -1/4 x plus 1. So that's your new equation. So you want to create an input-output machine right there. And it says to choose values for x. Notice it doesn't choose -2, -1, 0, 1, and 2. It chooses -4 and positive 4. And the only reason it does that is to where you're not, since you have that fraction right there, if you use numbers like 1 and 2, you're going to have fractions when it's time to plot, and that makes it a little bit tougher. But you want to run that equation in an input-output machine. So if you have something that looks like this is what I mean by an input-output machine. Your new equation is y equals negative 1/4 x plus 1. Using the values they give us, this is your x value, this is your y value that's going to come out. Your x value they gave us at first is 4 and 0. I'm sorry, negative 4 and 0 and 4. So when you plug those in place of x, negative 4 times negative 1/4 is going to be a positive 1. So you wind up, and that's just plugging it into this spot right here. 1 plus 1, just to shorten it up a little bit, gives us 2. Negative 4, negative 1/4 times 0, which is x's values this time. Anything times 0 is 0, plus 1 will be 1. And then negative 1/4 times 4 will give us a negative 1 plus 1, which leaves us with 0. And that's where these values come from, 2, 1, and 0. So the third step told us to just go ahead and plug. Once we have x, these are x comma y. So this solution is negative 4, 2. Notice right here, x comma y. So it tells you to go to the left 4 times and to go up 2 times. So from the origin, you go to the left 1, 2, 3, 4 times, and up 2 times. There's your first point. The second one, 0, 1, tells you don't go left or right at all, but go up 1 time. So there's your second point. And then your third one tells you to go to the right 4 times, 1, 2, 3, 4 times, and don't go up at all. 4. So there's your third step. Okay, here's the checkpoint. It says use a table of values to graph the equation x minus 2y equals 1. The first thing you need to do is you need to create function form, or you want to get y by itself. So move this positive x over by subtracting x, which you got to subtract x on both sides. What you're left with now is negative 2y equals 1 minus x. Then you want to get rid of negative 2 times y by dividing by negative 2. Divide by negative 2, y equals, because these will cancel, negative 1/2 minus 1, plus, it's going to be plus because it's a negative divided by negative 1/2 x. And again, reorder that to where it's mx plus b form. So your new equation will be y equals 1/2 x minus 1/2, or x over 2 minus 1/2. Okay? Um, and then using the numbers negative 3, 1, and 3. And I just picked those using the picture that I looked at. Negative, when you plug in negative 3, it becomes 1/2 times negative 3. That gives you negative 3 over 2 minus 1/2. Negative 3 over 2 minus 1/2 is going to leave you with, just like this, and I'll put it out here so we can show it. Negative 3 over 2 minus 1/2 will give you negative 4 over 2, which simplifies to negative 2. Okay. When you plug in 1, it'll be 1 times 1/2 minus 1/2, so it'll be 1/2 minus 1/2, which is 0. And then when you plug in 3, it'll be 3/2 minus 1/2. 3/2 minus 1/2, which is 2 over 2, or 2/2, which is 1. So now you have 3 different xy values. The first one is negative 3, negative 2. The second one is 1, 0. And the third one is 3, 1. This tells you to go to the left 3 times and down twice. So from the origin to the left, 1, 2, 3, and down 1, 2. There's your first point. This one tells you to go right 1 time and not up at all. So to the right 1 time, there's your second point. And this one tells you to go to the right 3 times and up once. So over 1, 2, 3, and up once for your third point. And then you just connect the dots. For vertical lines and horizontal lines, in the horizontal plane, the graph of y equals b is a horizontal line, where y's value is always constant. This is just showing you that it's always constant. Like y's value equals 2. If this was 1 and this was 2 right here, y's value is 2 for this one, for this one, for this one. It's always 2. That's why y's value is that. Notice this one says x's value is 8. That the fact that it's a or b doesn't matter. It's the fact that a's value or x's value is constant the whole time. X is 1, x is 1, x is 1. It doesn't matter what your y value is. X is 1. It'll give you a vertical line. Example number 3 is graphing y equals b. Notice your y value is the same for each of these. It's all -3. So it doesn't matter what your x value is, it's always going to be -3. It doesn't matter what number you plug in place of x. So the graph of the equation is horizontal line 3 units below the y-axis, or where y's value is -3. And then the last one, where x's value is constant. Notice your x value is 2 for all of them. The x value is 2. Um, no matter what your y value happens to be, your x value is always 2 on each of those. So it's 2 units to the right of the y-axis. It'll always be vertical. So where x is constant, it's vertical. Where y is constant, it is horizontal.